now we can just instruct the robot to go to the sideboard and bring us something. Bring me the multivitamin juice from the kitchen counter.
I am going to bring you the multivitamin juice.
So now, using what it knows about the object, where it is, it just repositions itself and selects a grasp, how it thinks it can reliably take this object. It recalibrates the hand to be able to detect failure and then tries to grasp it. So in that case, that failed, but it will probably try again. And in this case, it succeeded. So what it will do now is it will come towards us and hand over the object. So now the robot is tracking me, or it should track me next. Yeah, okay, now it is. And it also knows where my hand is. So if I now move my hand over here, it can track where that is to be able to hand it over to me, and then I can just pull and it will give me this object.
As a roboticist, you have to understand different things. If you are building the machines, you have to understand the mechanics, the electronics, the control. But this is not enough actually. You need the understanding of perception, how to recognize, for example, objects, detect objects in order to grasp them. If you are interested in building cognitive architectures like the operating system of the robot, you have actually to look into neuroscience, into developmental psychology, into human research. What do we know about humans? What do we know about, for example, memory systems in humans, how we function as humans, and how much of that can be implemented, for example, on a technical system? I think robotics is fantastic. I mean, we really need these insights from these areas, from these fields to build the robot brains, right, on the one hand, and to understand actually how humans react to interaction with machines in order to build intuitive interfaces, in order to build robots with which humans can interact and communicate in a natural way, and in order to build machines which are actually accepted by humans.
Hello, my name is ARMAR 6.
My name is Janna Nefzer, and I'm a researcher here at KIT, and I work with humanoid robots, and the topic of my PhD is failure detection and recovery. As we humans know, you tend to fail, or there's always some cases where you fail. And if you want to have like really autonomous robots that can deal with all kinds of situations, it's required that they can also deal with different kinds of failure. So now we will be able to see in the visualization that we update the scene. So currently the robot is looking at the scene, it takes a picture, also including depth information, and then we segment the objects in that and map that back to the depth information. And now we have an updated image, and now we plan a lot of grasps on all those objects. We try to first grasp the objects on top, and then you can see in the background there were many green hands, which were plant grasps, and then we ranked them due to some matrices and try to execute the best one. So what we are working on in this lab is like heavy tasks. That's why those robots are also like a little bit bigger and can lift heavier objects. And in this scenario, we want to decontaminate parts of power plants, of nuclear power plants, and then the challenging task there is to detect the object within a cluttered scene. So what we don't have here, or what we have here, is like a lot of different objects we don't know, and they are also stacked on top of each other, and it's like very chaotic, and then you need to figure out which object to take out first and where to grasp it and how to grasp it in a manner that it's stable. So where we're starting from is the challenge to grasp those objects. How do you plan those manipulation executions or actions? So the goal is that we develop methods you can use for such tasks, and then the industry can employ them on their robots. It's super interesting because you can see what you did as the robot moves. So you have something physical you influence somehow, and at the same time it's super interesting because you use very new technologies and you can use robots in like a lot of scenarios. They are very versatile, so as you can see here, we have them in maintenance tasks, we have them in very heavy object lifting, but we also can employ them in household scenarios. It's really complicated and really fascinating.